Good evening, boys and girls. I hope you're having a great afternoon. So I'm just gonna go ahead and do a quick review on today's lesson for those of you who had a few questions. Don't worry though, tomorrow we're gonna continue with it. I just wanted to make a quick video just to reference today's lesson and so we can have something to go from tomorrow. Okay, since we do have a short amount of time, I don't want you to stay with like more questions than you already have. So I'm gonna put the first example, which is what we saw in the classroom. So this is a simple number line. I want you to look over here at point A and point B. If you remember from yesterday's lesson, or I'm sorry, Monday's lesson, we did talk about the points being labeled with a capital letter. So you'll see the dot and you'll see the capital letter. So here we have point A and point B. And so pretty much here we're gonna count. We're measuring the segment. So we have segment AB. So segment AB. And we're gonna go ahead and measure it. So simply put on this one, we can simply do the 1, 2, 3, 4. So we know the length from A to B equals 4. Okay, so that one, shows pretty simple and stuff. But where we had a lot of questions or a lot of concerns and where we actually stopped because we didn't, we ran out of time, was the segment addition postulate. So pretty much the segment addition postulate is, let's assume you have a segment right here. So let me use another color. I work best with like different colors, right? So let's say we have a segment right here. And it's labeled A, C, and then let's just say here we have point B. So in the segment addition postulate is pretty much we're adding part. Let's say this is part 1. And then we're adding it with part 2. So that we can get the total. So pretty much what this is telling you is, if we have A, B, and C as collinear points, they're collinear because we mentioned in the previous lesson that points that are in the same line are considered collinear points. So you can assume here in the segment addition postulate, you can assume that this in a formula setup pretty much would be AB, which is your part 1, plus BC, which is your part 2, equals to AC, which is your total. Okay? So a simple example is if A, and let me use the green marker. So let's say AB equals 9. So we have, let me write down here, AB equals to 9. So here we know is 9, right? And BC equals 28, right? So we have 28. So we know that in order to get our total, so in order to get our AC, which would be our total here, we would need to add AB, which is our part 1, to our BC, which is our part 2, to get our total, which is our AC. So by adding our 9 plus our 28, we would get 37. So this is our answer. So I'm going to do a more complicated one, which is where we pretty much froze today, right? So we're going to say if EG, I'm going to put it if EG equals to 71, let's find the value of X, right? And this is what it looks like. So we have points E, we have point F, and we have point G. So we know, or also let me finish labeling the problem, and then we can go from there. So the problem has this here. We have AX minus 17, and you can find this problem in the examples files that I posted this morning. That's how it's labeled. It says U1 D3 examples. So you can follow along, or you can see the problem written out. But this is how it's written out. I'm just changing the colors. Okay. So we know from the problem, so let's go back to the problem. It says if EG equals 71. So let's start by underlining the important stuff that is given to us. So EG equals 71. So we know EG, the total, this is our total, this is our part 3, total is 71. We already know this because it was given to us in the example. So now it's telling us to find the value of X. So we are looking for this. We are looking for X is what they're asking us to look for, right? So let me go ahead and start writing it out, start breaking it down. So we're gonna go ahead and write what we do know. So we have AX minus 17 plus 5X minus 3 equals to 71. Okay? So just so that we're clear on that one, we're gonna break it down a little bit. So 8X minus 17 is our part 1. This is our part 1. EF. 5X minus 3 is our part 2, which is FG. Those two parts we know total 71 because that was given to us already. So then what we'll do is let's start, adding common terms here. So what we'll do is let's go ahead and add the x's, right? So we have 13x because we added the 8x plus the 5x. So we get 13x, and then negative 17 or minus 17 minus 3 is minus 20 equals to 71, right? Okay, so we're there so far. So what are we gonna do next? We want the x to be on its own because we are finding the value of x, right? So we're gonna go ahead and add 20. So these can x out at 20. So we have 13x. And let me move on to another color. So we have 13x equals to 91. What do? We divide by 13. We divide by 13. This x's out. So then we have, let me do a division over here. So once this x's out, we have x by itself equals to 7. This is what our problem was asking us. We needed to solve for x, I'm sorry. We needed to solve for x. So we found the value of x. X equals to 7. So I'm gonna go ahead and end on this example, and I'm gonna post another one. But for now, so you can review this one, and then I'm gonna erase all of this and record another one that might be a little more complicated, but I want you to have like separate videos to reference to. Thank you all.